so a group of friends are playing a game that involves rolling a standard 6-faced die on a table. The table is covered with a black and white striped tablecloth, like so, where we have white, black, white, black. And one friend notices that in approximately 1/3 of the tosses, the die ends up lying within a single stripe, as you can see over here. Develop a mathematical model that may help explain this observation, taking into consideration that the width of each strip is about twice the side length of each die. We've labeled that the side length of the width of each strip is 2x, and we've labeled that the length of each die is just x.
Here are the assumptions to the dice problem. Number 1, table size doesn't matter. The reason for this is that the length of the die is always proportional to the width of the stripes. So regardless of the number of columns, you will always have the same proportion of die to width. Number 2, the die never falls off the table. This just means we don't have to consider it in our calculations. Number 3, the table is perfectly flat. This means that there's no friction and it will always land on the table. Number 4, the die is not biased, meaning it has equal likely probability of landing on any side. Number 5, strip width doesn't matter because likelihood is always proportional.
We've got 2 examples of when we're looking at the minimum and maximum of which our probability can lie in. So in this example, we've got when theta equals 0, which is this angle here for our dice. So when the width is x, because theta equals 0, it's covering half the amount of space within the strip. That means that the probability of it lying within the strip is a half, which you can work out here. L1 is the probability of the dice landing when theta equals 0. In this example, L2 is the probability of the dice landing in the strip when theta equals pi over 4, which we decided is the maximum. The probability that this die can land within the strip is the space it has to manoeuvre, which is 2 minus root 2x, which we've got here, over the total distance of the width, the total width of the strip, which is 2x. You can see here that is 2 minus root 2 over 2. Therefore, we know that the true probability, which should be around 1/3, lies between 1/2 and 2 minus root 2 over 2.
Now that we have discussed what happens between the interval of 0 and pi over 4, we can now use these figures and the formula that we have just formulated to be able to find the mean function. Now, during our further mathematics course, or those who were lucky enough to study it, we were told that the mean function of a function would look something like this. So an integral between b and a, you would do 1 over b minus a and integrate through f of x like this. So we're going to apply something very similar here. As we know that our maximum value is pi over 4 and our minimum value is 0, we are going to sub these in. So 1 over pi over 4 minus 0 integrated between pi over 4 and 0 of 2 minus root 2 cos pi over 4 minus theta over 2 d theta. At this stage we are going to take the half out. So we are left with 4 over pi times by 1/2 of the integral between pi over 4 and 0. So 2 minus root 2 cos pi over 4 minus theta d theta. Now, in A-levels we learn about the angle expansion, and we are going to apply the angle expansion of cosine here. So we are going to be left with minus root 2 cos pi over 4 cos theta plus sine pi over 4 sine theta theta. Now the rest of it, so we are left with something looking like this. And with this element, it becomes 2 over pi, as is evident. Now, we can tidy this up a little bit more and we can leave this as minus 1 cos theta plus minus sine theta. So we are left with 2 over pi between pi over 4 and 0 of 2 minus cos theta minus sine theta d theta. Now the integral of minus sine theta is cos theta, and the integral of minus cos theta is minus sine theta. So we are left with 2 over pi times by pi over 4, 0, of 2 theta minus sine theta plus cos theta. Now when we sub in the values that we've got outside the brackets, pi over 4, 2 times pi over 4 will give us pi over 2 minus sine pi over 4, which is minus 1 over root 2, plus cos pi over 4, which is 1 over root 2. So essentially when we're doing our calculations later, they will cancel out. Now when we put 0 in, we get 0 minus sine 0, which is 0, plus cos 0, which is 1. So essentially we are minusing 1 from this bracket. So we are left with 2 over pi times by pi over 2 minus 1. Now when we simplify this, we can see that 2 over pi is pi minus 2 over 2. So we can see that 2 pi minus 4 over 2 pi will be our answer. Therefore, and this is equivalent to 0.36. Therefore, we have a mathematical model which shows that the probability of throwing a dice onto this carpet is approximately a third.
Hi, I'm Thomas Smith. Thomas Smith.
1 over pi over 4 times a half.
Shit.